Thank you once again, everyone, for joining. So we can get started with today's session on why microservices adoption is crucial for SaaS companies. In today's context, organizations are in a constant quest to look for solutions that can get them much higher agility and be able to vastly improve the time to market with the continuous working improvements into the production environment. Microservices precisely brings this agility along with a bouquet of benefits and hence has gained a lot of momentum in the recent past. And this is equally critical for SaaS companies, given the fact that SaaS products eventually keep growing, and hence it's very important to be able to operate in a lean and efficient manner without too much of a overhead or maintenance related issues. So in today's session, we are going to take a deep dive to understand more about the microservices and how it is different from the current way of doing things. And we'll also look at some of the use cases that calls for a microservice kind of an adoption, and then the advantages that one can get out of microservice implementation. We'll also look at the set of principles that one should follow or adhere to while carrying over these microservices related implementation projects. So with that, we'll get into our today's session. A quick note about Aspire. So Aspire is a services focused company, predominantly working on the areas of SaaS certification, working with several ISVs. In addition to some of the enterprises with focus on BFS and retail domains. And we are present across in multiple regions across the world. And at this time, we are a CMI level 3 company with a total headcount of around 2,000, close to 2,500 people in size. A few housekeeping instructions. So all your phones are set to mute. If you have any questions, you can feel free to type them in the questions window that you have. We will be taking up these questions at the end of the session, and we'll try to answer as many as we can given the time. And if we are not able to answer, we'll ensure we send across our responses or an email to you. And this presentation that we will have today will be sent to all the registrants. So you can expect a copy of this presentation after this session. A quick intro about today's speakers. I am Janaki Jayachandran, Technology Director. So I have around 18 years of experience, predominantly in the area of SaaS, and I have worked with several ISVs towards enabling and SaaSifying their products. And I've also worked with some of the microservices projects that we have undertaken and implemented for our customers. Our second speaker for the day is Jyoti Rangarajan. She is a principal architect and she has contributed extensively towards building several SaaS and PaaS solutions. She is a chief architect of the Techcello framework, which is a SaaS-based framework that can be used to develop microservice-based SaaS products. And she does a lot of consulting work with several of our customers on the areas of SaaS and architecture. So our first part of the session, we'll get into the basics of getting an understanding of the microservices itself, and then look at some of the advantages and the use cases related to it. So before we begin, let's take a step back to understand what is driving the need for microservices. Why microservices now? Right? So if you look at the overall strategic goals of any company or any organization, Some of the key goals related to the context of our discussion are enable a scalable business model for the company. And this is extremely true and vital for SaaS companies. We have seen a lot of SaaS companies being successful, but for some reason the products are not able to scale, and hence they kind of leave out the whole opportunity in spite of putting a lot of hard work. So having a scalable business is extremely important for SaaS companies. And the second aspect is the operational costs that comes along with the SaaS model. And SaaS itself being a very lean business model, companies have to be extremely efficient in terms of their operational and maintenance related aspects. And hence, keeping those costs low is very vital. And there is a continuous need for innovation. So you need to experiment. Um, in today's context, people don't bother about failing, but you need to fail fast and learn from the mistakes. So you need to have an environment that will allow you to do this kind of an experimentation and being able to continuously evolve. Now these strategic goals, if we convert it to from a technical perspective as architectural goals, some of the things that we need to take care are having an architecture that can reduce my cost of change. And as we just saw, change is inevitable in the given today's context, and agility and speed are the sole goal of all the enterprises and the ISVs. So I need to have an architecture that will facilitate me changes pretty quickly without too much of a cost being spent on that, and also avoid any accidental complexity. In the sense, many times uh, people are rather not aware about the complexity that gets built into these softwares. So if you take a SaaS team, they start building a lot of functionalities, they start adding a lot of features, and eventually over a period of time, pretty quickly the product gets pretty big and vast and complex. So if you are not designed it and architected it for that kind of a complexity being handled, so it's going to be a nightmare in terms of the operational maintenance aspects, right? So those are some of the key goals. Like the maintenance itself is one of the key aspects. So it's not about just building things today, but then making it work today, but then down the line, how good I can or how easy it is for me to maintain that and being able to serve my customers, right? And having a consistent interface in terms of data flow and things like that. So if this further gets translated to some of the design and delivery practices that are put in place, if you look at many of these are some of the standard things we do, right? So having REST-based services made available. If you have legacy-related stuff, then encapsulate the a kind of an API-based approach. Uh, have an integration model in place, right? Have small independent services. Don't have something big. Try to have it smaller and componentize it. A continuous deployment. DevOps is pretty much now a de facto way of dealing with the life cycle of the application itself. So many of these practices, if you look at, is what precisely the microservices kind of enables an organization, and hence this is kind of naturally being driven to address some of these practices that are required to achieve the strategic goals. So taking a quick look at so what's the difference between the older way of doing things, which is typically called as monolithic applications. And there's also something called a service-oriented architecture, which was kind of pretty popular maybe a decade back. It started, and today we have this microservices. So where do we draw the line between these things? Of course, it's easy to compare a monolithic versus the other two, because monolithic being a single large application which is not kind of layered in an appropriate way, and hence it becomes just one huge big iron box in a room kind of a thing. So very difficult to kind of maintain it, and requires a lot of manpower, right? A lot of cost involved. So I think that's pretty much given. But many times people tend to ask this question, okay, how is microservices different from SOA? Is it not one and the same? Is it not another version of SOA, right? So the fundamental thing what we do here between the SOA and microservices, the granularity of how we are breaking up the whole system, and that forms the fundamental difference between the SAO and microservices. But the idea of separating the applications into smaller parts is nothing new, right? It's always there. It's there in SOA as well. But then what has happened today is there are other programming paradigms which is addressing the same concept, um, like the SOA itself. But the technology advances that has happened today, coupled with the increasing expectation on digital experiences, that has given rise to a new breed of development tools and techniques, right, in the form of DevOps, in the form of continuous deployment, continuous testing. And hence, there is a need to meet these aspects of it to build a modern business application. So that's a high level differentiation, but to make it more specific, if you have to compare some of the key aspects of the SOA versus the microservices. So in SOA, the services that are defined can pretty much have a wide range in size. That could be, for example, a small functionality or a small component being projected as a service, but at the same time, you could project a large functionality, right, as simply as a service. So the size of how you componentize this widely ranges in an SOA case. Whereas in a microservices, the default thumb rule is to keep the microservices at a unit level. So ideally, it should serve a single purpose. Right? A service should not try to do more than one unit of functionality or work. So it's more of single purpose services. And SOA on the other hand, from a sharing perspective, it expects maximize sharing, which is you try to share as much as you can with the entire set of other services. Whereas in a microservices, what we call the bounded context recommends to do minimal sharing. So you just share what is required only to the concerned stakeholders, right? So that way you are keeping it kind of minimal. At the same time, the maintenance of it and the down the line, the organization of it becomes much more easier when you do that. You might have heard the middleware term quite popular with SOA, because many times middleware and enterprise service bus ESB is being used as the mechanism for interactions and integration between the SOA components. Whereas in the case of microservices, is typically the integration is done in the form of APIs, REST-based APIs. So that's again middleware being a heavy one and versus compared to REST-based API, a lighter one. The whole concept of DevOps and the continuous delivery is not something that is fully gotten into the SOA kind of architecture. It's more a nice to have kind of a thing. But then microservices, the entire base of it is embedded with the concept of the continuous delivery and DevOps. Because as we saw, the entire idea is to see how we can make these changes and change it, make it fast, and being able to have these things available in production in a pretty fast turnaround time. The last one is also around the databases that are typically used in SOA. So traditional relational databases is what is typically used. But then in today's context of microservices, there is again a wide range of database that is being used, and the biggest advantage is now each microservice can itself decide. The teams managing those microservices can actually decide the best database suitable for the nature of functionality that is being served with that microservice. So they could go for a NoSQL database, could be RDBMS, that could be file system in some cases. So it's completely open. So looking at the some of the advantages, right, of why to get into microservices. Of course, microservices increases the complexity a bit, but then it's worth the advantages that we are going to see now. Right? So of course, the independent and faster deployment is one of the biggest business advantage an organization can get, particularly for SaaS companies. Uh, there will be constant requests for features, changes, small enhancements, and hence being able to have a faster deployment, and also the fact that these deployments can be done independently, right? So when you break down your SaaS application into, let's say, segment into like 10 microservices, deploying a single microservice is much more easier, less time consuming, less error prone compared to trying to deploy the entire SaaS product, because there is a whole lot of effort involved in terms of verifying, post production efforts and all of that. So the biggest advantage is you can now independently take things without impacting the others and being able to roll it out successfully. You also get the advantage of the fault isolation, because we see that some cases one bad API call, one bad logic can crash the product. And in a SaaS world, that's something that's not acceptable. There's SLAs involved, there's availability clauses in place. So you don't want that risk to be in place. So one of the advantage we get with microservices, with the segmentation we are able to do and the isolation we are able to enforce, even in case of any issues, any faults, that kind of impacts only that particular service, microservice. So that's something that kind of creates an insulation for the other microservices. So, and addressing that particular microservice and then restoring it quickly, it's much more easier as well. So that's another great advantage we get. And there is also the other advantage where, in case if you have different teams, different technologies that you are planning to use, right? So some teams are comfortable with certain type of technologies, or they feel that particular technical requirement can be better served, better designed and constructed by using a type of technology. Earlier, we used to see this concept of the entire stack being .NET or the entire stack being Java, but that is kind of moving out, and people have started now looking at what is the best technology or tool that fits aptly for the given technical requirement. So if you foresee that a particular, let's say, a business rule is a microservice you are creating, so those microservices could be, let's say, well created using Java as a language, because you are having libraries available to support these kind of business rules. Then it might makes a lot of sense to build that using a Java technology. So whereas the rest of the application or the microservices could be on .NET or any other technology as well, right? So you can really leverage the various technologies that are available today and get the best of breed solution out of it. The DevOps, the continuous delivery, is something that is embedded with microservices. So we just saw the earlier point also around the faster deployment. Right? Ease of maintenance, again, this whole thing results in a lot of less effort in terms of the day-to-day operations, in terms of the rollouts, in terms of post-production efforts. And all of this in turn boils down to saving cost as well. The other biggest advantage we get here is what I call the selective scaling. Now, in case of the monolithic applications, large SaaS products, we have seen that the entire product can be scalable, right? So you have one big VM, which is of course going to cost you a certain amount. But then when you want to scale out, you add more similar sized VMs to the whole product. And the whole product is now running in each of those VMs. So it's a load balanced environment. But then if you actually look at it, the the performance or the load is actually only on some of the portions of the software, right? It could be, for example, an order processing related functionality, or it could be a notification functionality, right? Or it could be a calculation functionality. But then just because of these 3 or 4 areas, you don't have to really take the entire product and scale it, right? So having something like this can really help you to pick or focus only on the required areas and have a scaling solution only for that, which means it's going to cost you much more lesser, and hence the overall operational cost is going to also come down. Microservices are very container friendly as well. And today, the entire containers in terms of Docker and other things have matured quite a lot. So having a microservice based solution operate on a container is a much seamless way of working today. Similarly, from a security and maintenance perspective, the isolation we do here really helps. So if you want to have some services highly secured, you could do that as well. Certain data has to be encrypted for certain services. It's much more easier to handle it today. I mean, if in a microservices model, right? So isolating the service also helps in this context. So moving forward to what could be some of the use cases? Where should I use microservices? Can everybody use microservice for everything? Of course not. Any technology, any solution has its own pros and cons. And of course, there are going to be best case scenarios and probably not the so best case scenarios as well, right? So one, of course, needs to give the right thought to ensure that the investments or the efforts being put by applying a microservices kind of an approach really benefits the organization both technically as well as from a business standpoint. Right? So looking at some of those cases, one classic case is the SOA related cases where today you are operating in an SOA model. So those could be candidates for upgrading, right? And you can upgrade them, redesign those SOA into what we call the microservices based architecture. So that's a natural upgradation that SOAs will eventually go through down the line. The other use case is where you want to publish some core services. So even in cases of SaaS software, or in case of enterprises as well, there will be a set of services which are very core to the whole product, the whole software. So they form the heart of the particular application or software, and hence there will be a lot of dependencies and a lot of integration that happens with these core services. So these are classic candidates to be designed as microservices and made available. So that kind of eases out a lot of these integrations, and particularly when you work with a large team, this becomes much more important and useful. Cloud migration. There are a lot of companies that are going through the cloud migration path now, and that's another a good scenario or a use case, I would say, where you can really leverage the cloud scalability by switching to a microservice kind of a model, right? So in the earlier example, like I said, cloud offers you a lot of unlimited scalability, and with today we have a lot of options around auto scaling and all of that. But when you want to really make use of like the container kind of tech tools or cloud-based scalable solutions. These microservices can really make use of such kind of an elasticity available in the cloud. And there are also some unique cases where the approach towards the solution itself will be more of event driven. So they don't fall under the classic UI based or a functionality based, but then it could be more of the microservice itself gets executed based on a certain event that gets triggered within the enterprise systems, right? So such kind of cases are also a classic case for microservices. So when it's more of event based, event driven, certain events calling certain microservices, and that has to be triggered in some other microservices. So that's another use case. We talked about the distributed and diversified teams. One of the biggest challenges with a large team is the communication, right? The communication overhead, collaboration that is required between the teams, and a lot of time is spent around discussing how two different applications or two different modules are going to be talking to each other, right? And the whole microservices approach simplifies that, or rather it gives a structured way of how two teams will talk to each other, how two systems will talk to each other, two modules are going to integrate with each other, and hence becomes a very good situation to be using the microservices when your teams are either distributed, working across in different geographies, different locations, or it could also be, like I said, you may have a .NET team, Java team, or a different technology teams. So they all can now really converse using the same language. And of course, when you have a large monolithic software, particularly in case of SaaS, what happens in SaaS products particularly is these products grow pretty fast. And they grow in a speed that sometimes you don't realize or recognize the growth and the complexity that is creeping in to such kind of softwares. So for SaaS companies, it's extremely important to take a look back at what they have and then see if it can be really managed efficiently. And if not, moving into microservice architecture is probably the best thing to do. And of course, you have legacy applications that are anyway due for re-engineering. It could be another classic case. There are also performance bottlenecks, right? So we, like I said, in a large software, there could be few areas that create bottleneck. Now, those are the areas you could identify, take it out of from the large application and have them separately, like the core services we talked about, publish them as some of the core services, and then have a scaling designed for such kind of services. So that will be a great way to solve these kind of performance bottlenecks, or rather like peak load scenarios or peak load usage cases. Let me also touch upon briefly the overall holistic approach that one should look at when you are planning to implement microservices. Um, each of these things has a lot more details, which I'm sure Jyoti will be talking in the next part, where we'll talk about some of the principles to be followed in each of these areas. But to give you a holistic picture, these are the 5 different areas that one should really think through before you get into the microservices part, right? So to start with the scoping, so the first step there is to see what do you want to define as microservices. How do you break down the components? What is the size in which I should break down? Should it be too small, or will I break it down too small, or should I break it down too big? So that's a conscious decision one should do, and there should also be a need for such kind of services, right? So if you're having too many tiny services, of course, the downside is you may have overhead in terms of the management aspects of it, like you do individual backups and infrastructure and all of that. At the same time, if you have too big, then you are losing the purpose of it. So you need to have a careful evaluation in terms of scoping what could be the microservices for a given business domain. The second is the presenting part of it. Like, so presenting is about once you know these are the microservices to be done, the first thing is to see how to or what are the kind of APIs I can make available for this microservice. It's very important for the teams to first take a whiteboard approach, list down the APIs, understand if these APIs are meeting the purposes, are they able to provide all the integration points. Because one of the common mistakes people tend to do is they jump into the coding of those APIs and then later realize that the API is not fully serving or there's some gaps or some too much functionality is covered within a single API. So it's very important to do a whiteboarding first, presenting the APIs. So the respective teams of those microservices need to present these APIs with the rest of the team, ensure they come to a common conclusion before they move forward. The traffic management is about how you organize these microservices to ensure that the load of the system is taken care. And in some cases, you may have to ensure that things are done gracefully, even if, for example, some of the microservices are not working, ensure that it's gracefully conveying that to the integrated system and then it's taken care. Data sharing, how the data is going to be kept will be another aspect to be thought through, particularly when you scale these services. There could be more than one instance of the services running, so you need to ensure the data is available common so that these services could share them. And finally, the monitoring piece. Now, this whole microservices architecture is slightly complex, and hence your standard monitoring approach will not work. So you need to have a monitoring approach that can really give you details at a service level, at a layer level. Only then you will be able to analyze the data. And all of this has to be supported with two important things. One, having the right infrastructure platform, because you need to have the right platform that can help you in terms of deploying these things. And the second most important thing is to have a company-wide, org-wide DevOps culture, an integrated DevOps culture between all the teams involved. So that's going to be a fundamental thing because automation is going to be extremely important here. So having a DevOps culture will be a crucial factor. So with that, I will hand it over to Jyoti.
Thank you, Janaki. Now, we did see the advantages of microservices. Now, we also need to understand that microservice is not a silver bullet, right? The microservice development and design is intricate. One needs to follow base principles while designing and developing microservice. And we are going to be looking at those key principles in this part of the webinar. This slide represents the 7 core principles for developing and operating microservices, right? We'll move on to these principles. The first principle is how microservices should be organized. Now, the unit of decomposition for a microservice should be based on the business domain functionality. For example, in an e-commerce platform, customer service, inventory, accounts can all be represented as microservices. Some tend to slice it horizontally, but which is never a good practice. Decomposing the microservice by domain provide you several advantages. This makes the API more stable and also the teams owning the services become more and more expert in the business domain. Now, some find it challenging to draw the boundary of the microservice itself. Now, a tip would be to embrace just the healthy dose of domain-driven design, which can help in deriving the right domain boundaries of the microservice. Moving on to the second principle, which is the culture of automation. Embracing culture of automation is mandatory in microservice architecture. When the number of microservices are less, we can get away with manual tasks, but that won't last long, right? Now let's assume that you take 2 months to build to microservice. When you have not optimized the platform and the automation, you're going to be spending an equivalent time in building the other microservice. Now, once so the growth or the scale at which you are optimized is almost flat. Once you bring in automation and you have a strong platform, then you're going to achieve a rapid scale, and hence to achieve the scale at cost, automation is mandatory. Automation is also mandatory for continuous maintenance of your microservices. Things that you should consider automating are the infrastructure itself. Now, I would strongly suggest to embrace the practice of IaaC, which stands for Infrastructure as a Code, as much as possible. Sufficient automated testing. I cannot just stress enough, a proper automation testing is key for a faster deployment, and hence this is a mandate and not an option. Now, continuous delivery from dev to every stage of the pipeline, be it integration, be it staging or production, the entire delivery needs to be automated. Now, the third principle deals with hiding the implementation details. Now, there is a common tendency between the microservices and people who are implementing it to share the inner implementation details, such as database. And this is a very big mistake, and this has to be completely avoided. The only way to communicate between services should be via nice API boundaries or messages. Every microservice needs to set bounded context, which is an explicit boundary within the domain. There are, of course, going to be a need for the models to be shared between microservices sometimes. As you can see in this diagram, in left there's a sales context and in right there is a support context. But you can see that some models are shared between these contexts, which happen to be customer and product. But if we dive to the detail, we can understand that the context of customer in a sales is completely different from a context of customer in a support. And similarly, the context of product from a sales perspective is completely different from a product in a support. Assume you're sharing the entire model of customer and product. Now, what happens sometimes is the entire other business domain details, such as ticket, defects, everything is shared to a sales context, which is not appropriate and which is not required. Every microservice needs to set the bounded context appropriately so that they don't accidentally share information and complicate things. Exposing information is costly, and it's very important to understand what needs to be exposed to other services and what is internal and what has to be hidden. The next principle is deploy independently. Now, this needs to be a norm and not an exception. Each microservice should be deployable independently. We need to give a deep thought to achieve this. Now, there are different models of deploying service, right? Now, There's a model where you can deploy multiple services per host. In a typical environment, let's say you have a web server like an IIS or Tomcat, you tend to have multiple microservices just hosted in a same server or a host. Now, there is another way where you can choose to just host a single service, right? Now, the problem with the right side is if there is a memory leak in one of the microservice, it's going to affect all other microservice, right? Now, though we have separated the concern during design and development and everything, after deployment, one service is tending to break the other. So, as much as possible, you should try to avoid such a model. From a cost perspective, of course, when you are dedicating a single server or a single host per service, it's going to be costlier. But that is where containerization techniques help because it gives you the same level of isolation as a service per host, but with a lower cost. Now, there are also other deployment options available, like completely going serverless. Now, this pattern is also gaining popularity, especially within cloud environments, and that's a very good pattern for lowering the cost as well because you mostly pay for what you use in cloud, right? Azure Functions or AWS Lambda is a um, valid example for a serverless function, serverless infrastructure where microservices are well suited. One another important consideration when you are going to deploy frequently and deploy independently is to verify that nothing is broken from your consumer perspective. This is where strategies like or testing strategies like consumer driven contracts are used. Expectations from consumers are made explicit by generating tests that represents those expectations and contracts. Every time in a deployment pipeline, when a release is made, the consumer contracts are then run to verify that nothing is broken. Now, this allows to validate the service independently without having to verify the entire end-to-end testing, which takes a lot of time. Other testing strategies of microservices are a combination of unit testing, system component testing, consumer contract testing, which we just talked about, and an E2E or an end-to-end testing. The right proposition and combination of all these would help you verify and deploy your microservices without having to worry if it has broken something. Sometimes it's not possible not to break a consumer because you need to change certain functionalities or introduce certain functionalities. Now, the key thing is we cannot force all the consumers to move to the breaking API at a single point in time. Now, there are different techniques to handle it. One is a coexisting endpoint where you keep and maintain the old endpoint until all the consumers move to the new one. Now, this model is quite simple from deployment and this also works well with service discovery. Now, other model is to introduce new versions. Now, this is needed when consumer need both the APIs or in fact multiple versions of API on a longer run. Now, this model is complex because it needs to maintain multiple versions of codes for the different API versions, and then you introduce a change, or when you are, let's say, fixing a bug, you will have to retrospectively fix in all the versions. Both models has its own pros and cons, but in a nutshell, both are expand and contract pattern, where once all the consumers have moved to the newer endpoints or versions, older endpoints and versions can very well be retired. Uh, Now, microservice is an architecture that optimizes around autonomy, right? In order to achieve the goal of moving faster, deploying quickly, we need to give power and freedom for the developers to do the job at hand. That's the reason why you need to embrace a shared governance model instead of a central party sitting and verifying architectures and so on. It could be a shared model where governance is inflicted. Now, also need to adopt self-service as much as possible, right? And from an architecture perspective, there are decisions that might push you into the hole of centralizing everything, right? And which could be a blocker for the microservices to move rapidly. Now, one common pitfall is your middleware pipes, right? So you need to keep the pipes as dumb as possible and just do the bare minimal. Like, for example, there needs to be governance around that all the microservices are having similar authorization policies or authentication policies and so on, but do not introduce domain specific knowledge more and more into the middleware. Keep the smarts to the microservices and keep your pipes to bare minimal and keep it down, right? And the same holds good for API gateway, right? Now, it's also a de facto that most of the microservices architecture embrace an API gateway, and they also tend to add more and more logic that is more business domain specific to the API gateway, which again is a killer. So, like the pipes, you need to keep the API gateway also as minimal as possible, or the functionalities of it as minimal as possible, and completely take the responsibility of the business domain just to the microservices. The next important thing, now, consumer first, go for a consumer first approach. A service exists to be called. When you do not have a documentation, nobody even knows that those exist, right? Hence, though it's not very friendly for developers, having a good documentation is mandatory in microservice. Now, Swagger has become de facto for this. Swagger all provides you an easy way and a constructive way to come up with API documentation, and it also allows to execute and test out the APIs easily. Hence, embrace such documentation tools and embrace Swagger if possible. And we also need to consider other details of documentation so that the core teams can discover more information, right? Now, having things like where to what events are published by the service, what events are subscribed by the service, and where you would be finding different documentation, where is it hosted, and things like that can help teams to collaborate better. The next principle is highly observable. I think it's one of a very important factor. Monitoring is the key aspect of microservice. You should try to use a centralized logging and an aggregated logs from each service instance. The users can search and analyze the logs, and they can also configure alerts that are triggered when certain messages appear in the logs. Right. Products like App Dynamics, New Relics all help here. And there is also an ability there to look at a high level and then dive deep and analyze. The usage of things like correlation IDs help in tracking things end to end. You can very easily track what happened from one service and how this call went to another service and how it all passed from different events and so on. Now that we have seen what microservices is all about and the principles of building it, now how do we migrate? Um, Now, it has been ever true that existing apps are not always built according to the latest approach, right? It also does not use the latest tools. And this is also true for microservice architecture. Most of the team want to migrate to microservice architecture, but they are not sure on where to start, right? It's great when you come across a solution that's really helpful in situations like this, and that's true with Strangler application pattern. Now, this pattern existed even before microservice architecture came into picture, but then this pattern offers an excellent guidance to team that want to move to a microservices approach. The Strangler application is based on the analogy of a vine that strangles a tree that's wrapped around. The idea is that the structure of a web application, the fact that web apps are built out of individual URIs that map functionality to different aspects of business domain, this gives a chance to divide an application into different functional domains and replace those domains with a new microservice based implementation, one domain at a time. So this creates two separate applications that live side by side in the same URI space. Over time, the newly refactored application strangles or replaces the original application and until you can shut off the monolithic app. Thus, the Strangler application steps are to transform where you create a parallel new site, coexist where you leave the existing site where it is for a time and redirect from the existing site to the new one so that the new functionality is implemented incrementally and eliminate where you remove the whole functionality altogether from the existing site and all the traffic is redirected to the new portion of the site. Now, with this, we have also covered how to migrate. This brings us to the end of the webinar. We'll take up the questions now.
Thank you, Jyoti. Yeah, we already have got a set of questions, and others feel free to post the questions that you may have. We'll quickly address some of the questions now.
Okay. So one question is how to achieve regression test to ensure the new software changes will not break fundamental features. I think I did touch upon that. So there are various levels of testings that can be automated. So as I discussed, at various levels you do it. One, to start with unit testing itself. The second, there's something called a service component testing, which allows you to test your components by stubbing out your external dependencies, right? So you mimic just the external dependency, but then it just does go through a network call. That's a service component testing. Now, a consumer contract testing is where whatever consumers you have for the microservice, the expectations of the contract in which they are using are typically given in the form of a unit, in the form of a test case that is executed in the pipeline. This also ensures that the consumers are not broken. And finally, there is always an end-to-end testing which can again be automated. E2E testing covers the entire functionality from the use case perspective or the user story perspective that achieves the functionality is not broken.
Thank you, Jyoti. The other question is around what are some of the drawbacks of microservice-based architecture?
Okay, so there are cons to the microservice approach. Now, the key one being you tend, because you have different teams, the communication overhead of the teams are high, and you need to have a proper collaboration mechanism between the teams to achieve uh, a proper seamless sharing of information. Formal documentation overhead exists because in this you need to have proper API documentation, as I also suggested. Need to have a service documentation for the core teams to go and discover information themselves. And you also, from an enterprise perspective, because there is a power, you also end up having non-uniform applications. While polyglot application is advantage sometimes, but it has other or I would say strategical issues in terms of finding development resources on various technologies and so on. And you need to have a very strong DevOps presence, because DevOps is a very key principle in achieving microservice, right? And of course, some of the things like logging, monitoring, all um, have to be thought about differently, because you need one view of the entire thing that is happening, though the apps are itself hosted separately. That's why the use of correlation and so on help you to have an end-to-end view. Most of the uh, tools like App Dynamic, New Relic all provide you that, and you can use those.
But I'm afraid we are running out of time here. So if the other questions, we will try to respond back over an email. Once again, thanks everyone for taking the time to be available for the session. I hope you all found it informative. Look forward to see you all during the next session. Thank you.